Hi guys, you're welcome to Halogenious Ideas. In this video, I'm going to be explaining software and programming languages. Introduction to computer software and programming languages. I'm going to be starting with an introduction. Talk about the system software, the application software, then we'll talk about computer languages, the fourth generation languages, then the web programming languages. Okay, so let's get started. So, software refers to a set of instructions or programs that are designed to perform certain tasks on a computer or other programmable devices. In the previous video, I spoke about computer hardware. I said two different components make up the computer. You have the software, the hardware. The hardware are basically the parts that you can feel, the parts that you can touch, the parts of the computer you can see, you can feel, you can touch them. But the software are the instructions that command these hardwares as to what to do. So it's a collection of code written in a programming language that instructs a computer on how to perform its various operations, such as calculations, data processing, communication, and so much more. There are two main types of software. We have the system software, then we have the application software. Okay, the system software, this is the type of software that is responsible for managing and controlling the hardware components of a computer. Examples include operating systems like Windows, the Mac OS, the Linux, as well as the device drivers and the utilities. We have application softwares. They are designed to perform specific tasks for end users. It includes a wide range of programs such as word processors, web browsers, games, photo editors, video editors, business applications, name it. Alright? So, talking of the system software is a type of software that provides a platform for other softwares to run on and interact directly with the computer. All right, the system software also serves as an intermediary between you the user and the computer hardware itself. All right, so it serves as an intermediary between the hardware and the application software, managing various tasks to ensure the efficient functioning of the computer system. Generally, system softwares are classified into three groups. We have the OS, the operating system, the utility programs, then you have the language translators. The first one we are talking about is the operating system. An operating system is a crucial component of system software that acts as an intermediary between the computer hardware and application software. Its main functions include managing hardware resources, providing a user interface, facilitating communication between software and hardware components, and ensuring the overall stability and security of the system. So, some of the functions of operating system, we have way more than this, but I just picked up a few of them. So, we have process management. The operating system allocates resources to running processes and manages the execution of the program. We have memory management. It controls and optimizes the use of the computer's random access memory by allocating space to programs as needed. We have the file system management, the device management, as also the user interface as well. So it provides a means for users to interact with the computer, often through the graphic user interface, like the Linux I'm on, like Windows. You also have command line interfaces, which we refer to as the CLIs. Okay, so type of operating systems that we have. Operating systems are crucial software that manage hardware resources and provide services for computer programs. We have several types, okay, each tailored to the different needs and the computing environment as well. So we have the single user, single task OS. So don't forget, single user, single task. This type of OS will allow only a single user to run only a program at a time. So the use cases, we have embedded systems, basic personal devices with limited functionalities. So for example, your hand calculator. So it is just one user. You can only perform one task at once. Your hand calculator. So simple embedded systems used in appliances as well. So maybe your just think of something actually. So just any single user, single task operating system. This is where it falls under. Then we have the single user multitask operating system. Okay, on my Linux operating system, I have a web browser opened where I'm doing word processing, and I have my OBS Studio that I'm using to record. If I will open my OBS studio for you, this is my OBS studio over here. You can see that this is recording, and I'm currently on a, what do they call it again, on a web browser, okay, on the Chrome web browser. So this is a single user on this Linux operating system, but I'm executing different things at the same time, okay. We also have the multi-user, okay, the use cases, most personal computers and workstations. Example, we have traditional personal computers like Windows, Mac OS, or Linux. You can be running multiple things at the same time using your operating system. We also have the multi-user OS, which supports multiple users accessing the system at the same time simultaneously. Use cases are especially in servers, mainframes, and other systems where concurrent user access is essential. For example, the banking system. Most banks have a centralized system where, when you want to send money to somebody through the counter, different agents of the counter are accessing the system at the same time, so that all transfers, we won't have to wait for this person's transfer to go before this other person's transfer will go. So everybody have access to the server. Just go there, post your transfer, and with the as soon as possible they'll try to complete the transaction. What I'm trying to say is that many people are having access to the same system, to the same computer at the same time. So we have servers, we have mainframes, then we have other systems where concurrent user access is essential. So example is, talk of mainframes, servers running Unix, Linux, or Microsoft Windows Server. We also have the multitasking operating system, allows multiple tasks or processes to run concurrently, okay. So in the case of the multi-user, they allow multiple users to access the system. Multitasking operating system allow multiple tasks or processes to run concurrently. Most modern personal computers, workstation, and servers, they use this particular type of OS. So examples include the modern personal computers, the laptops, the workstations, the Windows, the Mac, or the Linux. So we also have the real-time OS. The real-time OS, they come in handy in situations where time is very, very critical, especially in the aircraft and in the medical field. Designed for systems that require immediate and predictable responses to external events. The use cases: embedded systems, robotics, aerospace. We also have medical equipment, especially those ones that are used for monitoring. So examples, we have the VX works used in aerospace or industrial automation. We have the free RTOS. Then in under the real-time operating system, we have two types: the hard real-time OS, then the soft real-time OS. So the hard real-time OS, we have strict deadlines for task completions. Failure to meet deadlines may lead to system failure. So this is an example. Then we have the soft real-time OS, which prioritizes tasks but doesn't guarantee strict deadlines. Some flexibilities is allowed. So examples include the Windows CE, the Linux with real-time extensions. So we also have distributed systems. Distributed operating systems, they manages a group of independent computers and makes them appear to be a single computer. So especially in networked environments, cloud computing, examples are Amoebas and Google's Future OS. So we also have the network operating systems, manages network resources, allowing users to share files, printers, and other resources. So if you are in an environment, especially in most offices these days, where you have to network different computers together, or you have a building where on the current floor you have just limited printers and you have many users that are supposed to be sending data to the printer. So this is one of the places where the OS comes in handy. So you'll be able to manage both the bringing the data in, executing the printing, and all those things. So use cases, talk of local area networks and corporate network environments. So and examples: the novel netware, the Microsoft Windows Server. We have mobile operating systems that are designed for mobile devices. Examples are Android, the iOS, the Windows Mobile. So part of the features: touchscreen support, mobile application ecosystem, and also power efficiency. So we also have the embedded OS, which are optimized for specific devices with limited resources. Okay, they are optimized for specific devices with limited resources. Um, a, a practical use case in environment might be the point of sales terminal. There are some point of sales terminal where you have Android operating system installed in them, and you have some point of sales terminal that are very very small, very like they are just the size of someone's hand. There is a space where you can slot in your card, and it has all the resources you need to charge your card have been embedded in the device. So embedded operating systems, it doesn't have many functionalities, just a device as small as that. All the resources it needs to charge your debit card have been embedded in that device, in that operating system. Okay, so that's what you call an embedded operating system. You also have it in your cars, where on automotive systems and IoT devices. So free RTOS, VXWorks, and Android things are examples. And the characteristics is that they are minimalist, they are efficient, and they are tailored to the device purpose. For example, Linux is tailored for so many things. Windows is tailored for so many things, but in the case of the embedded OS, it is tailored for only one thing or just a few things. But it has been optimized for just that purpose. Okay, we also have the time sharing operating system that allows multiple users to share the computer simultaneously by dividing CPU time among them. Examples include the Unix and the Linux, and the use cases if you have large mainframes, ensuring fair use of computing resources. You also have the multi core and parallel operating system, optimized for systems with multiple processor cores, enabling parallel processing. Examples include the Windows, the Linux, the Mac OS, capable of utilizing multi-core processors. So the use cases, modern computers and servers with multi-core processors. We also have the virtualization OS. So this enables the creation of virtual machines, allowing multiple operating systems to run on a single physical machine. Examples include the VMware ESXi and the Microsoft Hyper-V, KVM, and the use cases for server consolidation, testing environment, and cloud computing. These various types of operating systems they cater to diverse computing needs, ranging from personal computing to complex real-time and distributed computing environments, and each type is designed to provide specific functionalities and services tailored to the demands of its intended use. All right, so that will be all for the operating system. Now let's talk about the language translators. So the language translators are softwares that convert high-level programming languages into machine code or an intermediate code that can be executed by a computer. This should be telling you something that the kind of code that we write sometimes is the kind of code that computers will not understand directly. So you use these language translators to convert the codes that we write into something the computer can easily understand, so it will execute and give feedback. So the major types include the compiler, the interpreter, and the assembler. So the compiler translates the entire program into machine code or an intermediate code before execution. So you can see the compiler. A good example of a compiled language is Java. So all the code that you have written that you want to execute, it will compile everything at once. Okay, it will produce the optimized code, typically resulting in faster execution. So the disadvantage is that it has slower compilation process and errors are detected after the entire program are translated. Okay, in the case of the interpreter, it translates and executes the program line by line, one line after the other one, after the previous one. So a good example of an interpreted language is Python. So it has faster debugging as errors are identified as they occur. No need for a separate compilation step. They are generally slower in execution as the translation is done at runtime. Okay, it's done at runtime. Compiling in the case of the compiler, all the codes it is being compiled before runtime, but in the case of the interpreter, it is done at runtime. So generally, compiled languages are faster in execution than interpreted languages. So we also have the assembler, which converts assembly language code into machine code. So it produces efficient code closely tied to the computer's architecture. Okay. The disadvantage of the assembler is that it is architecture dependent, meaning that if you change the hardware, you may have to modify your assembly code. So that will be all for the language translators. Then the last type, we have the utility software. So utility software consists of programs designed to perform specific tasks related to system management, optimization, and maintenance. Some common types include the antivirus. For example, we have the SmartDAV, we have the Avast, we have the Kaspersky, we have a lot of other antivirus too. We have the disk cleanup tools, backup and recovery software, system optimizers. We have the file management tools and so many other type of utility software. So, in summary, system softwares, operating system, language translators, and utility software collectively form the foundation for effective operation of a computer system, providing essential functionalities and ensuring a seamless user experience. So that will be all for system software. That will be all for system software. Now let's talk about application software. So, for the application software, they refer to a category of software designed to perform specific tasks or provide specific functionalities for end users. Unlike system software, which manages and supports the computer system, application software directly serves the need of individuals, businesses, and organizations. Okay, so some of the different types of application softwares that we have the ones used for word processing, we have the spreadsheet software, we have the presentation software, we have the database software for managing and organizing large sets of data, providing tools for data entry, retrieval, and reporting. We have the graphics and multimedia software, we have the web browsers, we have the email clients, project management softwares, talk of Asana, Jira, Microsoft Project, Trello, talk of accounting software, QuickBooks, Sage 50, Zero, CRMs that you refer to as customer relationship management. For example, MailChimp, GetResponse, a lot of them, Salesforce, HubSpot, Zoho CRM. Then we have the enterprise resource planning software. So it integrates core business processes such as finance, HR, and inventory management. We have the educational software, we have the communication software, we have the gaming software, we have the utility software. Okay, so within the application category actually. So this performs specific tasks to assist in system management, optimization and maintenance. Talk of the WinRAR that is used for file compression and extraction. We have the CCleaner, we have Dropbox for file synchronization. So we have so many other type of softwares, application softwares. So you can just check them out. So these examples they represent a wide array of application software demonstrating the diversity of functionalities available to users across various domains and industries. Each type of application software serves specific purposes, addressing the unique needs and requirements of users and businesses. Okay, so let's talk about computer languages. Computer languages, also known as programming languages, are used to communicate instructions to a computer. These languages vary in their complexity, their abstraction level, and ease of human understanding. Here are three main categories of computer languages. We have the machine language, low level, then the high level languages. For the machine languages, this is the lowest level programming language consisting of binary code that directly represent the instructions executed by the computer's central processing unit. Okay, each instruction corresponds to a specific set of binary digits, zeros and ones, and this is machine dependent, meaning it is specific to the computer's architecture. In machine language, an instruction might look like this, just 101100, like that. So we also have the low level language. Low level languages are more human readable than machine language, but it is still closely tied to a computer's architecture. They provide a closer representation of the hardware's functionality. Okay, so type of low level languages we have assembly language. So this assembly language they use mnemonics and symbols to represent machine instructions. So characteristics they provide knowledge of the computer's architecture, they also provide direct access to hardware components. Okay, so this is what an assembly language will look like. So these are comments. These are comments. So in this case, you have registers BX and AX. So this MOV, you might be telling the depending on the hardware that you are on. So this instruction might be telling you to move the value 1 into register AX. In this case, register might be acting in place of a variable. Then you have AX and BX. So just add the value in register AX to the register BX like that. So we also have high level languages. High level languages are designed for human readability and are independent of the computer's architecture. They use natural language constructs and are easier to understand and write. So they are abstracted from the hardware details, making them more portable. So easier to learn and use compared to the low level languages. This is what Hello World, if you want to print Hello World with an exclamation mark, yes. So you also have in Java. If you want to print hello world in Java, this is what you do. In C sharp, in JavaScript. So high level languages abstract away so many details, allowing programmers to focus on the logic of their program without being concerned about the intricacies of the underlying hardware. Each type of language has its own advantages and use cases, and the choice often depends on the requirement of a particular project or application. For example, if you want to build a mobile app, you might be talking in terms of React Native or Flutter. If you want to build a web application, if it is one that needs, or if it is one that requires just the front end, you might be talking about React JS. If it is one that React JS, Vue JS, or Angular. I don't think anybody uses Angular anymore. So if it is one that has to do with the backend, you need a backend for. You are going to be doing something like you are going to be using the Laravel, the Django, or the Node.js. So yeah, if you have to connect a database to it, you are going to be using MongoDB, which is the NoSQL, or MySQL, which is for relational databases. So, like I said, they have their own advantages and use cases, and the choice often depends on the requirement of the project, okay, or the application. So, some legacy computer languages that we have these programming languages that have played significant roles in the history of computing. So we have BASIC, which stands for Basic All-Purpose Symbolic Instruction Code. It's a high-level programming language designed for beginners, and it is known for its simplicity and ease of use, making it an excellent choice for educational purposes and early personal computers. This is what printing Hello World would look like. We have the COBOL, which stands for Common Business Oriented Language. It's a high-level programming language primarily designed for business applications. It focuses on readability and is known for its English like syntax, making it suitable for writing programs related to finance, payroll, and other business processes. So you can see how what it looks like. So we also have the formula translation, which everybody refers to as Fortran. It's one of the earliest high-level programming languages, especially used by mathematicians for numeric and scientific computing. So if you want to write a program, Hello World in Fortran, this is what it looks like. We have the PL1, which is the programming language one. It's a versatile high-level programming language designed for scientific engineering, business, and system programming. So it includes features from both the Fortran and the COBOL, and this is what it looks like. Okay, we have the RPG. The RPG is a high-level programming language initially developed for business applications, particularly for creating reports. It evolved over time to support more general-purpose programming, and this is what it looks like. This is what it looks like. Okay. We also have the Pascal, which is a procedural programming language designed for teaching programming, and it's a good software and good software engineering practices. It has a strong type and encourages structured programming. This is what it looks like. Then we have the C. C is a powerful and widely used programming language. So it is known for its efficiency and flexibility, especially flexibility. It has had a significant influence on many modern programming languages like the C sharp, the C++, Java, Yeah, and Java. So you can see the preprocessor directive and the main function, which will stand as the entry point for execution. So each of these programming languages has its own strengths and was developed to cater to specific needs within the computing landscape. They have contributed to the evolution of programming languages and have left a lasting impact on the field of computer science. So let's talk about the fourth generation programming languages. So they are high level programming languages designed to simplify the development of software by providing a higher level of abstraction compared to the earlier generations. They are often used for database programming, report generation, and business applications. So they are declarative, they are database oriented, and they are user friendly. All right. So examples will include the structured query language that we refer to as the SQL, VB that we call Visual Basic, we have the Power Builder, and we also have the MATLAB. So the MATLAB is used for numerical computing. This is what the Power Builder is used for. So this is used for rapid application development because it is easy to use, and this is used for managing and querying relational databases. So now, object oriented programming is a programming paradigm based on the concept of objects, which encapsulates data and the methods that operate on that data. It promotes the principle of encapsulation, inheritance, and polymorphism. All right, encapsulation, inheritance, and polymorphism. So, encapsulation, you might call these three the three pillars of object oriented programming. So, encapsulation is basically you restricting access to data. So bundling of data and methods that operate on data within a single unit. We have inheritance, mechanism for creating a new class based on an existing class, inheriting its properties and behaviors. So just like a parent class and a child class. As a child, you have some features that you have inherited from your parents. This might be the color of your hair, the color of your skin, your height, and all those things. All right. So we also have polymorphism, which stands for existence in various forms. All right. I hope the sound of this knockout is not entering my recording. Oh God. So examples of the object-oriented languages, examples rather. So we have Java, we have C++, we have Python, then we have C Sharp. So C Sharp was developed by Microsoft. Python supports both procedural and OOP. Okay, so it's an extension of the C programming language with additional OOP features. Then this is a versatile and widely used object-oriented programming language. So I'm a Python person, but if I would write any other programming language, it would be Java, obviously. So web programming languages. Web programming languages are used to build and develop applications for the World Wide Web, ranging from simple websites to complex web applications. So the key components. Um, Talk of front end languages, back end languages. Then we have the ones for full stack development and the one for web development. For the front end languages, they are used to create user interface and control the presentation layer. So HTML, CSS, and JavaScript. HTML are used to define the structure of the web pages, or you can say it is used to define the elements in the web page. CSS, styles and formats, you use it to define how these elements are going to be presented. Okay, then you use JavaScript to add interactivity and dynamic behavior to web pages. We have the backend language, the PHP, the Node.js, which is JavaScript on the server side. So PHP is strictly server side. It's a server side programming language. We also have Python with frameworks like Django and Flask. Okay, so versatile language for the web development. Then we have Ruby on Rails as well. For full stack development, any developer that is proficient in both the front end and the back end are referred to as full stack developers. So if you want to do the front end, you might be working with frameworks like React, Angular, or Vue, but the back end you have to be doing it with any of these backend languages. Talk of PHP, Node.js, Python, or Ruby. So we also have these other frameworks. Okay, so just the same thing I explained upstairs. So these programming languages and paradigms are integral to different aspects of software development, catering to a wide range of applications from database management to web development. They empower developers to create diverse and sophisticated software solutions. So that would be all for computer software. We started by defining what a software is. We spoke about system software, application software. We spoke about computer languages and the fourth generation languages. So thank you very much for watching to this point. Don't forget to like the video, subscribe to the channel, and drop your comments. We appreciate them. So thank you very much. I'll see you in the next tutorial. Bye for now.